Hello there and welcome to another Fusion 360 related video regarding the OS Railway project. And in this video I will show you a chassis that I've made for those of you who want to make your own train and don't want to make the chassis and the bogies and the transmission and all that. So you can focus on the body and the outer looks. So this chassis is inspired by trams, and the unique feature of a tram is that it's usually built to be able to cope with very narrow track radius and very tight turns. So what it means is that, for example, bogies can be placed in the center of the rotation points like I've done here, or they also often have the bogies mounted only on the center car and you have outer bogies like this. So it reduces the number of bogies compared to long distance trains where you have long cars with 2 bogies on each car. And what this does is that when you have narrow track or tight track radiuses like we have here, you don't get a lot of sideways movement between the cars when you go through switches and stuff like that, which makes it really hard to do something scale-like. And obviously, of course, also it will reduce the number of parts you need to print, and it will also reduce the assembly time because you have fewer bogies to work with. And I will include links in the description, so you will be able to download this as a CAD file on Thingiverse. And you can just import it to your Fusion 360 and get started. I will also include links to other useful things you need to know about this, because this is based on, for example, the GP38 locomotive that I have on Thingiverse. So it's the same motorized bogie, which incorporates a 3D printed gearbox and also adapted for a 380 size electric motor. So you can buy a cheap 28mm diameter RC motor, which is available on eBay and other vendors as well. So in this video I will show you how to make a super simple body for this. So before we get started, I always recommend that you create components and try to divide projects into several components, which makes it a lot easier to keep track of what you're doing. So in this case I have created a component that is called forward body. And also one thing that is important to keep in mind is that when you import CAD files into Fusion 360, if it's not a Fusion project you're importing, your history timeline below will not be activated by default. So that can be really annoying, that if you start working with something, you create lots of drawings and lots of features and you want to go back in the history and suddenly you notice that the history is not there. It's because it's not turned on, so you need to right click and you need to click capture design history. So in this case I have already done that, so my history is active down here. So let's get started. You could approach this in several different ways. As always with CAD, there's always many different ways of doing things. So you can either start by making a side sketch of the profile of the train, or you could, if you want, you could start with creating a front profile of the train. It's a matter of taste and also what kind of blueprints and drawings you have. So in this case I will start with a side sketch, because I think personally it's simpler to get an idea of how the train is going to look when I draw it from the side first. So what are the dimensions to keep in mind here? First of all, it's where the track comes, and that is I placed this in the CAD so that the origin is right at where the top of the track is. So obviously we want some clearance from that, so maybe between 5 and 10 millimeters up at least clearance we want there. If you're not building any bridges or slopes or anything, you could go even closer if you want to, but I recommend that you at least keep some clearance there. And the other thing to keep in mind is that we don't want our body to extend too far, too close to the rotation point, because then the bodies of the side bodies and the center body is going to collide when you go through a tight turn. And we can use this, which I called turn analysis. We can use that to show how this actually works. And what you can see here is that this is the narrowest turn or radius that I have, and I've made it so that you could extend the body a little bit out from the chassis on the sides and it'll still not collide. So you have at least 4 or 5 millimeters that you could extend the body on the sides of the chassis, and we're actually going to do that in this case. So the body doesn't have to be placed only above the chassis, it can also go on this along the sides. So let's get started, and we will use the end here as a reference. So click P for project, and we can we can click the edge here, and that is a good reference point to start with, and we will create a sketch from there. And now I'm just improvising something here. And I'm not using rounded edges here, and you will see in a moment why I'm not doing that. Because I understand that this looks a bit weird, but there is actually a reason for this. So I will try to imagine now that when these points here are rounded, how the shape is going to look. So let's do something like that to start with. And it's of course possible to go back and change this later, so we don't have to put too much time here right now. So let's put in some dimensional restraints. So we have 10 millimeter clearance to the track, and also the overall height 80 millimeter. So let's finish this sketch, and what we can do now is we can go ahead and extrude this, and we choose symmetrical. And that means when we draw here, it will do the same thing on the other side. And you can see now that the chassis is 60 millimeter wide, so we have 30 millimeter on each side, and we will extrude a bit further so our body can go further down on the sides, on the outside of the chassis. So let's add, let's see, let's add 2 extra millimeter there. And make sure also that it's trying to create a new body, and so that it doesn't want to cut or do anything else. We want to make a new body. So this looks really weird, and now I'm going to explain to you why we did these sharp edges here. Because what I've seen is when you do a really simple body like this, one of the reasons that it doesn't look scale-like is when you have a flat side that is the same width the whole way up, it doesn't look scale. So what we want to do is we want to have a narrower part up here, and we also want the body to be a bit narrower down here. That will make it look a lot more scale-like. So to be able to use simple tools in the CAD, we will use these edges all the way around, and I will show you how to do that. So click on the front and click a new sketch, And what you see now is now we can actually use these edges here. And we will make the body narrower in the roof, and we will also make it narrower down here. So let's close these. You can see that the area turns blue when it's possible to create an extrude from it. Now we're only making one side because we can mirror the feature later. So click Finish Sketch, and you can either mark the two areas first and click Extrude, or you can do it the opposite order. It doesn't matter. But what we're going to do now is that we're going to remove material. And when you do this, if you're removing one area where there's part of the chassis and part of the bogie there, it might try to remove material from that as well. So what you can do here, you can click on the objects to cut, and you can make sure that it's only trying to cut the body that you're working with. And we can see that it's only doing that, so we click OK. And now we're going to make sure that it does it on both sides, so we can mark the feature and we can click Mirror. So the feature is already selected, so we will select the plane, and it can be a little bit hard to find it, but let's see. Now it's probably visible that I'm clicking the center plane here, and click OK. So now if we look from the forward side, we can see that the roof is a bit narrower, and also the bottom here. So now we're gonna try to round these features off. So let's see in which order we want to do that. Now this might take a couple of tries, because you can do this in different orders, and that will create entirely different results. If we, for example, start with these and press fillet, and this one, oh, that was a bit too much, and we take this one, I can see it already starts looking a bit more like a train. And what this does is that you can see now that we're maintaining this line here. So let's go ahead and round these off too. Now this might be very hard to manually pull this to a good result, so it might be easier to just enter some values and see what happens. And as you can see, these are so different, so I think we're gonna go ahead and do them individually instead. So this one, for this one, 20 seems to be okay, and for this one we want a higher value. Oh, not 450. Something like that. Now, what you could do, because you obviously want to have this on the other side as well, you can go back to the history and you can double click on a feature, and you can hold in Control and you can select one more edge and click OK. And for the upper one, we also want it to affect the other one as well on the other side. So there. So let's now try to round these off. Now you see that it's also trying to round this lower edge off, but we don't want that. So what we could do then is we could actually remove this one, because now when we click fillet, it will stop here at the sharp edge. So let's try some values here and see what happens. Now, as you could see, it was really hard to pull the arrow there because we got an error message quite rapidly, but it was a lot easier to just enter some values and see what happens. You can also try here to see how big values you can enter. Okay, 20 was too much, so 18, 19, 19 is probably around the biggest radius we could use. I think that might be a bit too much. So let's try with, yeah, let's try let's try 14. Yeah, that could work. I'm going to now to try. I'm going to show you a different method here, because if you think like I'm thinking now that the nose section here, or what you would call it, it looks a bit too wide. I want it to be narrower. So I'm gonna show you now an alternative path. So I'm actually going to remove all these rounds, all these fillets, and I'm going to show you a different method. So what I'm going to do now is I'm going to make this narrower before we start to round off all these edges. And we could do this, there's several ways we could do this. We could do it with a sketch, and we could remove material, but we could also use the chamfer tool. And before I do that, I want it to align with this point here, so I'm going to check my sketch, and I'm actually going to put in some dimensions. I want to know, for example, how far back this edge is. Okay, it's 15 millimeters. And I want to know how far back this point is. Okay, 45 millimeter. So let's use the chamfer tool and try some things here. We want to use two distances, and we know one of them is 15 millimeters, but that actually did not work, as you can see, because we already have introduced an angle here. So let's see what we can do about that. Let's try to bring this a bit further back. See what happens. This is a matter of trial and error, and you can try many different values and see what you think looks the best. I will try this and see how it works. So again, we need to think about in what order we want to round this off. I still want these lines to be one quite big rounded edge. So I need to make sure that Fusion recognize this. So I'm going to, as we did last time, I'm gonna start with these two edges. And next is this one. And now we introduced some more edges. So if I click here and I click fillet, Fusion will think that that this edge is actually broken here. So what I'm gonna do is I'm gonna create a fillet here as well. Now I see that I could actually make these with different dimensions, so I'm gonna do separate fillets for these. For the lower ones, I want to keep this small value, but for the upper ones, I want to have a bigger value and see what that looks like. I think this will make actually a much better look. What happens now when I press fillet or F? You can see now that Fusion recognizes that this is one long edge that we can make a fillet on. So let's try some values. Now we have a much more complex geometry, so this might get us into trouble, and we can see that it does. So let's see what we can do about that. Let's go ahead and remove the lower fillet here and see what happens. No, it didn't like that. Let's try with a bigger value there and see if this works better. So it's this small edge here that is causing trouble. I'm gonna see if I can get a better result if I make this radius here a bit smaller. So let's make these two with different radiuses and see what happens. No, still doesn't want to cooperate. So let's try another method. We completely remove the fillet down there and we concentrate on this upper edge. That worked. As you can see, the more features you introduce, the more trouble you get. So yeah, try to keep things simple to start with. You will have a lot less trouble. So we could do like that. And now let's try to make a separate fillet down here and see what happens. That's interesting. I'm surprised that worked. Yeah, yeah, that worked surprisingly. Now you could actually keep this sharp line here as a feature, or we can go ahead and put a fillet on it. That's a matter of taste, I guess. So now let's not put any more time into the shape of this one. Let's assume we're happy with the result. Now there are different ways that we can make this a shell, and I'm going to show you at least one of them that I like to use. And I try to use the shell command when possible, but if you have too crazy of geometries, you sometimes end up with situations where this tool cannot actually calculate the things right. So that might make it really difficult. But in this case, I hope that we can use it. Yeah, we could. There's no errors. So in this case, I made it 1 millimeter thick. I think that's a good size. If you're gonna print with FDM, then 1 millimeter is actually quite good. It usually works and it doesn't get too heavy, and we can add features and we can add reinforcements inside if we want to.